Okay, in this last experience with the minerals, we are going to calculate the density of a mineral. So during your examination, I will ask you potentially a question about the methodology for the calculation of density of any mineral, and yes, we will be able to discuss some properties of minerals. So for example, I could tell you that the specimen has a specific volume, and I know the weight of the specimen, and so I could potentially ask you to determine its density based on the volume and on the weight of the specimen. So how do we measure the weight? We have a scale here, so usually you measure that in grams. So in this particular case we are examining Galena, which usually has a density around 7, and so we have roughly a weight for this specimen of 130.3 grams. So that's your mass M, and if you remember, the very simple formula is usually density dE, it's equal to a mass divided by a volume. The volume usually is expressed in cubic centimeters, and because of that, usually we have water, and we determine the volume based on immersion strategies. So in this case we have roughly 320 milliliters. So here we have 320 milliliters. Milliliters of water, and we need to make essentially a difference between the volume that results from the immersion of this crystal of Galena, and in this case it's looking like it's 345 roughly. So it will be 345 minus this 320, which gives me 25 milliliters really. So this would equate to 25 cubic centimeters, if I am correct. So if we have a volume here and also a weight in grams, we should be able to determine the density by simply rounding this off and doing 130 divided by 25. So if I have a calculator, I can calculate that very quickly. So that would be 130 divided by 25, and it gives me roughly 5.2, which is close enough. Sometimes you will not get perfect result if you have that the specimen has other things in it, and so you need to have 100% Galena to be able to reach the same density. And also the way I have measured the volume is quite approximative. So in this particular case, it's looking like this value could be lower, so 340, and so the volume would be smaller, so it would be 135 divided by 130 divided by 20, and which gives me 6.5, which is much closer to the approximate 7 value for Galena density. But that's I think correct, so it makes sense. I think it's a good and rapid way to estimate density. I recommend you review this for your examination, and it's certainly an interesting experience to actually measure density of minerals and figure that out. 7 is quite high. If you think of quartz, for example, it will be on the 2.7, 2.5, or 2.6, that range. And so it's easy to distinguish minerals also by looking at their density. This completes our series on minerals. I will not spend further time. The next lab will be rather dedicated to rocks, so we're going to look at the igneous rocks and identify igneous rocks, which will be also quite important. So remember this method of estimating density. I might ask you a question: how do you get the density of a mineral? And you'll have to explain me the methodology, and I might ask you to do a quick calculation.